All right, so let's go ahead and do a quick review for our functions quiz. So let's take a look at this first example here. We have f of x equals 1/5 x plus 7, and it says here x equals 10. So basically what we want to know is what is f of x if x is 10? So we're going to say, okay, f of 10 equals 1/5, and again, since we're saying x is 10, so it's going to be 10. So 1/5 times 10 plus 7. So, okay, so what is 1/5 times 10? So remember what I told you, times the top divided by the bottom. So what's 10 times 1? 10 divided by 5, 2. So this becomes 2 plus 7. And 2 plus 7 is 9. So when x is 10, f of x is 9. All right, next example. Over here to the right. F of x equals negative 20x minus 10 if x is negative 3. So if we say here, if x is negative 3, this becomes negative 20 times negative 3 minus 10. So then we multiply here. Negative 20 times negative 3, that's positive 60. And 60 minus 10 is 50. So when x is negative 3, f of x is 50. All right. A few more examples here. Over here, we threw an exponent of 2 in here. So it says f of x equals 4x squared minus 2. So what if x is negative 9? Okay, so if x is negative 9, this becomes 4 times, use parentheses when you substitute for x. It's going to help you. So this is a negative 9, right? Squared minus 2. So now we have here negative 9 squared. Remember for PEMDAS, exponents first. So negative 9 squared, think about what is negative 9 times negative 9. Well, negative times negative is positive, so that's positive 81, okay? So this is going to become 4 times 81 minus 2. You can get rid of this. And 4 times 81 is 324. And 324 minus 2 is 322. So when x is negative 9, f of x is 322. Okay, next example here. Now this is a little different. This one says, what is the value of x for which f of x equals negative 20? So what that means is now I'm not telling you that x is negative 20. I'm telling you that f of x is negative 20, and I'm looking for x. So when I write this, I'm going to actually write, instead of f of x, I'm going to write negative 20 equals negative 3x plus 10. Now hopefully you see what to do here. We're just solving this equation. So next I'm going to subtract 10 from both sides. This cancels out here. On the left I have negative 30, and on the right I have negative 3x. Then when I just divide both sides by negative 3, I get x equals 10. So when f of x is negative 20, x is 10. So that's answering this question. What is the value of x for which f of x equals negative 20? All right, 2 more examples. Word problem, your favorite things, right? So it says here, Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. Identify the independent and dependent variable. Write a function for the total amount collected from ticket sales. Let T represent the number of tickets to sell. Find a reasonable domain and range for this function. So let's go ahead and take this one step at a time. So first, it says identify the independent and dependent variable. So remember, you have to think here, okay, what depends on what? So if you think about it, the amount of money that Manuel brings in depends on the number of tickets he ends up selling, right? So that means money depends on tickets. So dependent variable would be here money, and the independent variable, sorry if my handwriting's a little messy, would be the tickets. So next, let's write a function. So when we write the function, we've already discussed, it's already told us, use T for tickets. That means T for tickets because tickets, that's our independent variable. So now what are we doing to the tickets? The tickets cost how much? $2.50 per ticket. So the number of tickets is getting multiplied by 2.5 or 2.50. So we're going to write here 2.50T. Now there's something else going on here. Manuel already has $20. So 2.50T plus the $20 Manuel already has. That's how much money he's going to have. So now remember, the other side of this, when you're writing in function notation, is very easy because we have f of and the same variable t that you used on the right hand side that just comes in here. So f of t equals 2.50t plus 20. Now, the next part, find a reasonable domain and range for this function. So think about what is reasonable to make sense here. We've talked about this. Is it possible for Manuel to sell a negative number of tickets? No, that's impossible. Can you sell half a ticket? Well, I guess you could sell half a ticket, but can anyone do anything with half a ticket? No. So, can he sell 0 tickets? Sure. He has $20 already. What if no one else wants to buy a ticket? So it's possible that he could sell 0 tickets. Could he sell 7 tickets? No, because he only has 4 tickets left. So that is how you come across the concept that his domain, or the reasonable domain for this situation, would be 0 if he ends up selling no tickets. He could sell 1 ticket, 2 tickets, 3 tickets, or 4 tickets. He can't sell more than 4 tickets because that's all he has. So then, how do you get the range from that? Is you go substituting these variables, these domain values, into this function. So if he sells 0 more tickets, you know that 2.50 times 0 is 0, right? So that becomes 0 plus 20. That means he's going to have $20. Well, what if he sells 1 ticket? Well, that's going to be the $20 he has plus $2.50, right? So 20 plus 250, that's going to be $22.50. And if he sells 2 tickets, now hopefully by now you see that you're just adding $2.50 each time, right? So he's going to sell then he's going to have $25. And if he sells 3 tickets, that's going to be $27.50. And if he sells 4 tickets, that's going to be $30. And so that is your reasonable domain and range. All right, one last example to look at here. This one's kind of easy. Which of the following sets is a function? So remember, we learned that in a function, each input value has only one output value. We learned that there's one way that you can do this is you can make a mapping diagram. We put all our x values in here. So we have 1, 2, 4, 8. And our outputs, our y's, can go here. If I do this in order, I have -3, 4, 5, oh no, -10, -3, 4, 5. So -10, -3, 4, 5. And so then we draw our arrows. So I got 1 to 4. I have 2 to -3. I have 4 to 5. And I have 8 to -10. So we can see here each input only has one output. So this is a function. Yes. Let's take a look at this next one. Okay, so here are my inputs. Here are my outputs. I have 2, 4, 6, and 2. So I have here 2, 4, and 6. And then my outputs are, I have -8, -3, 2, and 5. So -8, -3, 2, and 5. So when I draw my arrows, I have 2 goes to -3. I have 4 goes to 2. I have 6 goes to -8. And then here I have 2 goes to 5. So here 2 goes to 5. And so right here we can see that the input of 2 has 2 different outputs. So this is not a function. All right, good luck on your quiz.